You're listening to Making Waves, fresh ideas in freshwater science. Making Waves is a bi-monthly podcast where we discuss new ideas in freshwater science and why they matter to you. Making Waves is brought to you with support by the Society for Freshwater Science, Arizona State University's School of Life Sciences, and the University of Washington School of Aquatic and Fisheries Sciences.
This is Eric Moody with Making Waves, the Society for Freshwater Science podcast. I'm here today with Dr. Robert Jackson. He's a professor of environmental science at Duke University. Thanks for joining me.
Thank you.
Dr. Jackson is a plenary speaker at the 2013 Society for Freshwater Science meeting talking about shale gas extraction and hydraulic fracturing. So what exactly is hydraulic fracturing and why is it such a big issue?
Well, hydraulic fracturing really is two steps. It's become a catchword for horizontal drilling, the ability to drill down and then out a mile or two through a relatively narrow formation. And then once a horizontal drill is in place, a mile or two underground, then companies can pump water and sand and chemicals underground at very high pressures and crack open the rocks that hold the oil and gas. So it's opened up new resources for oil and gas in the U.S., and instead of having declining production now, production has been increasing for the past 5 years or so.
Why is it all of a sudden, is it the new technology that has been developed that's really allowed us to start extracting energy in this method?
The combination of the two technologies together is what's new. I mean, hydraulic fracturing goes back to the 1940s, and horizontal drilling goes back to the 1980s or so. But companies started to put those two things together and use much higher volumes for the hydraulic fracturing and much higher pressures for it too. So the two things together, that's what's new.
Hydraulic fracturing, also known as fracking, has become a fairly controversial subject among a lot of people in areas where this is taking place. So what is the controversy all about? People
have concerns about a couple of things. They're concerned about drinking water and water quality around them, particularly the possibility that the chemicals in fracking fluids or some of the naturally occurring chemicals deep underground might leach or escape into drinking water. That's one of the biggest concerns. They're also concerned about air quality effects, everything from dust to hazardous pollutants or carcinogens like benzene in air, toluene, xylene. They're worried about these chemicals drifting downwind and people breathing them because in many cases the well is only a couple hundred feet from people's houses.
One thing that you mentioned about this method of energy production that's very different from a lot of other ones is that the infrastructure is in some cases really in people's backyards, and that makes a big difference in how people view it. Is that right?
Correct. You're talking about a large industrial process right next to where people live, next to a dairy farm, next to people's lives. I think that's part of the controversy.
So one of the concerns about fracking is that it leads to groundwater salinization. What are the concerns involved with that?
The possibility that fracking can contaminate drinking water or groundwater comes from a couple different ways. First of all, people are concerned about the chemicals that are placed in the fracking fluids. Again, some carcinogens, hazardous pollutants, acids, things like that. There's another source of possible contamination, though, and that's the salts or the metals, the radioactivity that's found naturally thousands of feet underground. And if that water or the chemicals in the fracking fluid leak out of the well and into the surrounding shallow drinking water aquifers, then you have the possibility for contamination.
Yeah, and one thing that you've mentioned is that in some cases it's actually the wells themselves that are failing that are causing some of the problems.
People's biggest concern is the chance that fracking might open cracks from thousands of feet underground all the way to the surface. I mean, in fact, where problems have occurred, it's something simpler. It's really about well integrity, in my view. It's about making sure that the cement that protects the outside of the well is in place, and making sure that the casings that isolate the gas and fluids coming up from deep underground from the surrounding drinking water are sealed well. So the issue of well integrity is the key to this whole process, in my view.
Is it difficult to install these wells, or what sort of problems lead to these types of problems occurring?
You can have cement that doesn't seal the outside of the well properly. What that allows is for a gas, for instance, to move essentially into the well space. So think of the gap between where the steel casing is and where the rock is. Mm-hmm. And companies fill that gap with cement. That's called the annulus. So if that annulus isn't sealed with cement properly, gas or things that are found at an intermediate layer can move into that space, up and then out into shallow drinking water. That's one way. The second way is more troublesome. That's if the casing itself leaks. If the casing leaks, then you would expect to find not just stray gases like methane or ethane or propane, the things that make up natural gas, but also liquids, chemicals, and other things that are coming from deep underground. So it's really a fundamental distinction between the two.
So one of the major papers that your group has published on fracking is that there may be potential for methane contamination. So what have you found in terms of methane leaking from these wells?
We found evidence that a subset of people living within a kilometer of natural gas wells are much more likely to have very high concentrations of methane, ethane, and propane, what we call stray gases. On the other hand, we haven't found evidence for the chemicals in fracturing fluids or for radioactivity or some of the deep salts and metals. So really the first thing and the only thing that we found is what we call stray gas.
Is that dangerous to human health, or is it not as bad as radiation leaking out of these?
Well, it's certainly not as bad as radiation or carcinogens, things like that. However, high concentrations of methane, as we found, can be dangerous, can be explosive and flammable. There are guidelines for keeping concentrations below certain levels so that you avoid those risks. And a number of wells that we've sampled, the drinking water wells that we've sampled, are above that level. The second question, though, is whether this stray gas contamination is an early warning sign for more contamination in the future. And I think if it's a casing problem, if it's a well integrity problem, it suggests that there's something wrong with that well. So if you have a casing leak, if you get these stray gases in water, it's a suggestion that there's something fundamentally wrong with the integrity of that well, and it needs to be fixed before these other problems might occur.
There's hydraulic fracturing happening all over the nation. In Pennsylvania, there's obviously the famous Marcellus Shale. There's work in Texas and Colorado, and there's a lot of variation in whether you're finding contamination in these different locations. So what's causing so much variation in whether these contaminants are potentially leaking out?
We think that we see evidence for contamination in a couple of different shale gas plays around the country. The Marcellus was the first that we worked in, and we published the first paper to look at interactions of water quality and distance to natural gas wells. And we just came out with a paper a few months ago with the U.S. Geological Survey that showed no evidence for contamination at all in Arkansas, in the Fayetteville Shale. So that's a good news story. And some of the differences that might contribute to that include geology. The Arkansas, the Fayetteville Shale, has a very tightly confined drinking water aquifer, so the geology is less fractured. The drinking water is tightly bound above and below by impermeable layers, so it's really an ideal situation for safeguarding that drinking water. It could be other things. It could be the people who did the drilling or the companies involved or particular rules and regulations. But we think geology is at least playing a role there.
Do you know if there is a lot of research that goes into the underlying geology before these wells are drilled? Are there any sort of procedures in place to say, this site might be more at risk for having problems down the road? There's
a lot of work that goes into it. The tricky thing here is that the companies do the geological work. They spend lots of money doing 3D seismic imaging down deep underground and then out. You can't get your hands on those data, though. That's the tricky part. Mm-hmm. So they have the information. You can't get that information.
So what would you say is the future for hydraulic fracturing in the United States? Is this going to be a sustainable energy solution for the future, or do you think that more work needs to be done before we can really conclude anything about that?
Regardless of what I think about the process as an environmental scientist, what's clear is that we are investing in unconventional natural gas and oil in this country. We're making a bet. It's the number one pillar of the Obama administration, number one fossil fuel pillar. Shale gas and tight sands, shale oil, they're all here to stay. So our motivation for the work and the research that we do is to reduce the problems that occur. In the minority of cases where something goes wrong, we want to understand why it goes wrong and how to keep that from happening somewhere else. The train has left the station in terms of investments, billions of dollars of investments in these different unconventional energy sources. The focus now is really trying to make it as sustainable as possible. Natural gas is much better than coal for particulates, for mercury, for sulfur, things that harm people when they breathe those compounds. But on the other hand, natural gas is still a greenhouse gas. So there are long-term implications there as it affects the pricing and the adoption of renewable energy technologies and things like that. But it's here to stay.
So one thing that I find interesting is your career started out doing a lot of work with plants and plant physiology. How did you make this transition where you've now begun working on hydraulic fracturing?
Well, it's not as far afield as it sounds like. I was a chemical engineer in college, and I went to work for the Dow Chemical Company for 4 or 5 years before I headed back to grad school in environmental sciences and ecology. So I was always interested in land use. I was in a natural resources school for my graduate work, and it's not so different measuring gas fluxes from the soil and measuring gas fluxes from a road or a well pad or something else, or measuring water quality in the soil or in an aquifer from some land use perspective versus an energy perspective. So it's really not so different. It's just a different system.
Do you find it interesting to be able to work on these systems where there is such a big sociological component as well?
Well, I do. We got into the shale gas business because there was a complete lack of peer-reviewed research in it. So that's the number one motivation. There was all this controversy and no data, all heat and just no hard data. So that's why I became interested and other colleagues at Duke became interested, and that's been kind of guiding our work since then in this area. For students and researchers in the Society for Freshwater Sciences, there are many research opportunities looking at downstream water quality effects, downstream benthic organisms. I think there are many research opportunities where the expertise of people here in the Society for Freshwater Sciences will contribute to this field.
All right. Well, thanks a lot for joining me.
Thank you, Eric.
You've been listening to the Making Waves podcast, brought to you with support by the Society for Freshwater Science. For more information on this speaker, the Making Waves podcast, or the Society in general, please visit us on the web at the Society for Freshwater Science webpage. Tune in next time for another fresh idea in freshwater science.